Okay. Whereas I guess on the tangent graph, since we've got an amplitude of 1, this point here would be at 1, and this point here would be at -1. Oh, that's terrible with my finger, but all right. Okay, so do you feel pretty good about the tangent and cotangent? Okay, yeah. I'm getting a few head nods. All right, so now let's move on. Let's see. Oh, here's an example of y equals 2 cotangent of x over 2. That's what we just did. Okay. So yeah, these other points would be 3 pi fourths and 9 pi fourths, and then plus or minus 2, as we said. In fact, I probably should have labeled those on my graph. Sometimes those are a little bit harder to figure out. This point here is going to be 3 pi fourths, 3 pi over 4, and then this point here is going to be 9 pi fourths. So I would expect you guys to label these as well. So not just the middle two as I did there. Okay. All right, so now let's talk about the secant function of x, okay? So remember, the secant is the reciprocal of the cosine function. So usually, I know, at least for me, it's a lot easier to draw, so, and it's kind of hard to see, but you got your y-axis here. So if this is your cosine function here, okay? Remember that, so if with the cosine function, let's see, we start here at the axis. So the cosine of 0 is 1. We're going to draw 1 cycle here, okay? Now, since we're doing reciprocals, 1 divided by 0 is undefined. So we're going to have asymptotes at all the places where the cosine term touches the axis. So we've got asymptotes here, 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 okay? Now, in this case, remember that the secant function is the reciprocal of the cosine function. And so basically you're going to have, so this is the secant function here. And then this little u thing is a secant, secant, secant. So it's going to repeat. So we've got several cycles on here. So your range, so your domain is all real numbers except for the odd multiple of pi halves, because remember at pi halves the cosine is 0, so 1 over 0 is going to be undefined. Your range is going to be y is greater than or equal to 1 and y is less than or equal to -1. Your period's still going to be 2 pi. You still got symmetry with respect to the y-axis. Your intercepts, you're not going to have any intercepts. It's never going to cross the axis. Your vertical asymptotes, like I said, are odd multiples of pi halves. And so if you have a point x, y, and y cannot be 0, because you've now we've got asymptotes there, then y equals then I'm not going to read that. Anyway, basically, we've got the cosine function here. I guess you can, when I was learning how to draw these, you would usually draw the cosine function because that was easy, and then you just draw these u's basically everywhere else, and then you could erase the cosine function, and you're left with just the secant function. So let's do this one. Graph. I don't know if I dare copy this because it was such a bad copy last time, but we'll try it. Graph y equals -3 times the secant of x over 2. So let's see here. Who haven't I picked on in a while? I think I skipped Texas yesterday. Today's your turn, Texas.
Sweet.
So tell me how to draw this. What should I start looking for? And if you want to start with the reciprocal function and then tell me the secant later, what's the reciprocal function?
So the reciprocal function be so secant is 1 over the cosine.
Cosine. Okay.
Right.
So your cosine. So if let's it may be easier to draw the -3 cosine of x over 2 first, and then draw the secant. Does that make sense?
Yeah.
Okay. So with if this were -3 cosine x over 2, we'd still need to know the amplitude and we'd need to know the period, right? Those are kind of the first two things we need.
Right.
Okay.
The amplitude would be 3.
3.
And the period would be 4 pi.
4 pi. Well done. Okay. So let's do the cosine function first. So if this is 4 pi, and then what's this point here in the middle?
2 pi.
2 pi. Well, these are too easy. It's kind of nice when you have an x over 2, because these make these really easy. And then this is pi.
Yep. And then the point in between the 2 pi and 4 pi would be 3 pi.
Okay.
It's actually nice whenever it works off a base 10 number system.
Yeah, it is nice. And oops, I forgot to draw my line. Okay, so we're going to do 3 pi here. Okay, so now, I don't know if you're going to be on camera though, because when your voice is there, and I know you're on camera, but I can't see your face.
I'll switch the microphone from my desktop to my phone. So
no, that's okay. It's okay.
Okay.
We'll have let's see who we'll have Mason. No, Mason's not on camera. Who's on camera? I'll pick on Cameron Rabbit. Okay, you're on camera. I can see you. So hand draw me the cosine function.
So wait, can you show it again, just so I can see it real quick?
So
Okay,
we're doing -3 cosine x over 2.
So
I just want you to give me the basic cosine.
So like start down from the origin and then go up like that, right?
Perfect. That was perfect. Okay. And we're going, so the amplitude is -3. So, and I'm glad you started on the bottom. So as far as this here, so this value here is going to be -3. And this value here is going to be +3. And, okay, so we've just drawn, we're going to draw with my finger here. So it's going to look something like that. Okay, now, I'll pretend that goes through the 3 pi. That's kind of annoying. Okay, so now, do I want to keep picking on Texas? Texas, do you want me to pick on you or somebody else?
I don't mind.
You don't mind? Okay, so tell me now, so now that we've got that in there, we need to start drawing in the asymptotes. So where do the asymptotes go?
So the asymptotes would be everywhere where the cosine crosses the x-axis. So it'll be at pi, 3 pi, 5 pi.
At pi? Oh, that looks like a terrible asymptote. Boy, my finger doesn't match where I'm trying to draw this. So I'm going to asymptote here and here. Okay, I'm going to change my colors now. We're going to go to red. And then, can you describe what I should draw in this region here?
So basically, it would be kind of like an upside down U, nearly touching -3.
So now we're drawing U's here.
Yep.
Okay. All right, well done. So this is going to be one period here. Now, theoretically, and I don't know how, just make it clear when you guys are doing this. At this point, I guess, if you want to, we can erase. So if this is a test question, you can erase your cosine function because we don't need it anymore. But, so that's going to be your -3 secant of x over 2, the red curve. Okay, does that make sense? All right, so I've got that drawn there. Oh, we're done. How about that?
I have a question.
Yes.
For any time you do a reciprocal, do you just leave, because with that one, it was -3 secant of x over 2, and then you changed it for the reciprocal, -3 cosine x over 2. Is that how it is anytime you do a reciprocal? All you do is just change the secant to the cosine or the cotangent to tangent. So meaning like the equation part's the same, you just switch out that one part.
Right, yeah.
Sense? Okay.
Yeah, that makes total sense. And you said it exactly right. Yeah. So we did the secant, but the cosecant is going to be the same way. It's just going to be shifted kind of like the sine is shifted. So, all right, good question.
So we don't have to do any math or anything to change it to graph it?
No, no. The easiest thing is to do is to either draw the sine or the cosine function and then draw the u's kind of where the peaks are, and then make sure you have the asymptotes in the right places. So.
Okay, thanks.
Okay.
Another question I have.
Okay.
Since we've learned about like modifying the sine, cosine, tangent, cotangent, and secant, what does it do to the circle specifically whenever we start modifying it?
It doesn't do anything to the circle.
It doesn't do anything in the circle?
All we're doing when we're doing any of these graphs is we're taking all the points on the circle and we're plotting them as xy's.
Okay.
So.
I just had to ask, so.
Yeah, no, that's fine. I have a feeling you guys are all too young, but maybe somebody will be able to answer this question. When I was a very young boy, which was much too long ago, my sisters got this really cool toy called a spirograph. Has anybody ever heard of a spirograph? Yeah.
Yes.
Okay. Oh, good. Now you didn't make me feel so old. Thank you, Corey. It was a cool thing back in the 70s. But the spirograph is the coolest thing because you can if you take the circle and then you put your pencil in like one of these holes, it will draw all of these sine waves and cosine waves, and we're going to get into a lot of cool
I did have one of those.
Yeah.
I just didn't know it was called that.
So it's not just it's not just an old toy from the 70s. That's good, because I swear I haven't seen it since I was a kid. But yeah, so that whole spirograph kit is all based on trigonometry, and it's really cool. And so we're gonna do some other things as we get into graphing here. So yeah, so the reason why I say that is to answer Texas's question. If you took a unit circle and then you draw it, you just put your pencil in the circle and draw, it will create these waves for you as you keep going. So.
Oh, that's so cool.
Yeah, it's fun. It's a fun toy, and we probably should promote it more because it's fun for little kids and they don't know they're doing trigonometry, but that's exactly what they're doing. To make all these cool shapes. So yeah, so basically if you take the tip of a circle and you just roll it on a horizontal axis, it will create sine waves or cosine waves or whatever you want. So all right, so we, believe it or not, are done with 2.6. So what I'd like to do is to do 2.7. And so with 2.7, and by the way, am I sharing? Can you see my?
You are.
Okay, good.
Yeah.
Okay, so we're going to talk about shifting things now, okay? So if I have a function of x, such as sine or cosine or tangent, and then I add or subtract some c, that c is going to result in a vertical shift. It's going to shift it up or down. If it's it'll up if it's a positive number, down if it's a negative number. So c is going to be a vertical shift. If, however, I put the c inside the parentheses, okay, so f of x plus or minus c, the c is going to result in a horizontal shift. And in trig, we refer to that as a phase shift. So the idea here is if we put all this together, okay, so if I have y equals a times the sine of bx plus c, the amplitude is going to be the a term. The period of the sine is going to be 2 pi over b. If we're using tangent, it would just be pi over b. And then your phase shift is going to be negative c. So it's going to be the opposite. Remember, if it's in the parentheses, you can use the opposite. So your phase shift is going to be negative c over b. And this works with both the sine and the cosine functions. We'll get into the tangent a little bit later. Okay? So we've got a nice graph here that kind of shows, let me think here. Okay, so the blue is your cosine. So 3 cosine 2x plus pi thirds. That's probably a little bit small. Let me make that bigger. So the blue is going to be cosine of 2x plus pi thirds. And then the red is just going to be 2 cosine of, or 3 cosine of 2 pi x. So you'll notice here, the red function starts up here at positive 3, and then it goes to negative 3 and back up. And now, essentially what we've done with so when we add the pi thirds in the parentheses, we're shifting it left, so it's the opposite sign. We're shifting everything pi thirds to the left, and then we're going to redraw that, okay? So you've seen it, but let's see here if we can do this ourselves, except for let's go.
I have a question.
Okay.
Did we learn the cosecant function graph? Or did I miss that?
I didn't talk about it. You've got the secant here, and the cosecant is just the reciprocal of the sine. So it's so similar. I didn't take time to do it, but
Just wanted to make sure.
basically it's a bunch of these just shifted 90 degrees, basically.
Okay.
So you're going to see a bunch of this as well.
Okay.
So just draw your sine wave and then draw a bunch of U's on at the peaks.
Okay, perfect. Thank
So
you.
it works out. It's exactly the same. All right. Okay. This is all in the notes, so I'm not going to save it. I'm going to open up a new blank page. Okay. So let's see. Can I paste that? Oh, it worked. That actually worked fairly nicely. Okay. So here's the idea. So I'm going to have you guys, we're going to draw our little graph here. Okay. Now, since we're having a test and we've done enough of these, who do I want to pick on this time? Whose turn is it? Chris Hardwick. There you are. So can you tell me what to do with this?
Alright, so the amplitude will be 3.
Amplitude's 3. I like how you went straight there. Okay.
The period will be pi.
Let's see, 2 pi over 2, so that's going to be pi. Well done.
And then
And let's talk about your phase shift. We haven't done that before.
Yeah. So the phase shift will be pi thirds over 2. So let's see. Would that be 2 pi thirds?
Yeah, so negative c over b. So remember, it's going to be negative. It's going to be the opposite
Oh,
sign.
negative. Okay, so
Yeah,
it'd be
2. So pi thirds divided by 3 divided by
2.
2. Okay, so that becomes what?
I think that's 2. So it'd be negative 2 pi thirds.
No, it's going to be negative pi divided by 6. Does that make sense?
So
Oh,
you
because
just
you're flipping and multiplying by its reciprocal. So instead of because it's being divided by 2, you're flipping it and multiplying it by 1/2. So basically, it's pi thirds times 1/2.
okay.
Does that make sense?
I guess so. I don't know why you'd flip it though.
Okay, so let me see if I can write it this way. Maybe here, I'm going to use Excel for a second. So if I got pi thirds, here, so this is my fraction. Pi thirds divided by 2. So 2 can be written as 2 over 1, right?
Yeah.
Okay. So as Texas said, when you've got a fraction divided by a fraction, we need to multiply this by the reciprocal, which is going to be 1 over 2.
Okay.
And so now you've got pi times 1, which is pi, and you've got 3 times 2, which is 6.
Gotcha.
That makes sense?
Yeah.
Okay. I ignored the negative, but you've still got the negative there. Okay. So your phase shift is going to be negative pi sixths.
I have a quick question.
Okay.
Why is it negative when it says plus pi over 3?
Okay. So remember, when I showed you this, when it's in the parentheses, it always goes in the opposite direction. So your phase shift, the formula is negative c over b. So since this is positive pi thirds, it's going to be negative pi thirds.
Okay, thank you.
So the rule is, and this is how I always tell people, I mean, you guys didn't take college algebra for me, but I always tell people if it's in the parentheses, it's the opposite sign, and if it's outside of the parentheses, then then you can keep the sign the same. So in the vertical direction, plus c is going to be plus c. If it's in the parentheses, it's going to be the opposite. So it's going to be negative c over b. So yes, these in the yellow here, these are kind of the keys to your graphing in this case.
I believe
Okay.
the same thing holds true for parabolas, if I remember right.
Yes, parabolas and everything.
Every other function.
Every other
Right.
function, ellipses, everything, circles. Yeah.
Okay.
Okay. So so we've got our phase shift. Now this is where these numbers get a little bit harder. Okay. So if we're going to shift, so essentially we're shifting our cosine pi 6, which is about 30 degrees, you can think of. So this value here is negative pi over 6. Okay. Now, if the period is pi, okay, so if we're drawing one whole period here, and we're going pi units from there, what is this value?
Five pi over 6.
Yes, 5 pi over 6. Okay, does that make sense? Now, let's figure out what this value is here. This value here is what?
Pi over 2.
Let's see. So if this was, let me think about this. If this was pi and we were subtracting pi 6, then 5 pi 6. So we're going to divide that by 2 again. So that would be 5 pi 12ths. I believe that's right. Let me make sure that's right. Oh, they didn't even write it on there. That's cheating. Oh, how rude. Let's see, it would be pi. So if this was normally pi, it would be pi halves minus pi 6.
It would be pi thirds, technically, if it was in the
Pi
middle.
halves minus pi 6.
Should be pi thirds.
6. Okay, so this would be times 3 pi minus pi is 2 pi. Yeah, it is pi thirds. You're correct. Okay.
Yeah.
Sometimes you have to think about these. Okay, so this is pi thirds. Okay. And then this would be what? This would, so normally, let's see, normally this, well, pi thirds plus pi sixth, right?
So
that
in
would
the
be,
one in the middle would be pi halves.
yeah.
And then
So this is pi halves. And then
one pi halves would actually be higher.
Oh yeah,
than
you're
pi
right. This
thirds.
is pi halves. I thought you, yeah, that's right.
Yeah.
Get rid of this. So what's this value here?
Let's see. Change your own pi thirds to be pi 6.
Pi thirds minus pi 6. Yeah, that would be pi 6.
Yeah.
Okay, so this is pi 6. Okay, so at this point, and then we're going up and down, how many?
3.
3. So that's 3. Okay, so normally the cosine function is going to start high. It's going to look like that, except for actually,
Wouldn't it go
it should
to
go
pi
right
6?
here. Yeah, I need to get rid of this. Okay.
I'm a little confused because I'm following you in the book, and just the graph they have for it, it starts at 3.
Right. Yeah, 3 is right here. Sorry, that's where 3 is, right here.
But it has them starting at 3 on the y-axis.
That's without the phase shift.
That's, yeah, exactly.
Oh, are we
You
doing
need to
it
look
with
at the
phase
blue.
shift? Oh, okay.
You're looking at the blue one
Okay.
with the phase shift. Yeah. The
Okay.
gray one is without the phase shift.
Okay, perfect.
So, all right. Any other questions on that?
Nope.
All right. So, I want to make sure we cover these. Part of me wants to go a little bit slower, but I want to get this so that we can have a good full day review. Yes, completely. So, the graph of y equals 2 cotangent of 3x minus 2. So once again, if our cotangent function is going to go through pi 6, they didn't draw in the asymptotes, which I think is terrible. I do want to see your asymptotes on here. So if we shift it 2 units, I really don't like. I'm trying to make this a little bit bigger. I don't like. Well, maybe I should leave that alone. I don't like that they. Number one, they didn't draw in the asymptotes here for the cotangent, which I guess is okay, but they've shifted it 2 units to the right, but it's hard for me to tell what that value is. And so I would like to know what this value is, and I would also like to see the asymptotes right here and right here. But at any rate, so the -2 shifts it to the right 2 units. So any question on the cotangent function there?
No.
Okay. Let's talk about the graph of y equals 1/2 the sine of x minus pi fourths minus 2. So the -2 is going to shift it down 2 units. The 1/2 is going to make your amplitude 1/2. The minus pi fourths is going to shift it to the right pi fourths. So if your normal sine wave starts here at 0, with the shifted, we're going to shift it pi fourths. So if you're drawing the, in fact, maybe, you know what, I want to do this one. Let's do this one slower. This one's going to be a little bit more complicated. Okay. Oh, darn it. Okay. Let's talk about this one because I think this one I don't want to go too fast on. Okay. So as we're drawing this, okay, we're going to get your amplitude equals 1/2. You're going to get, it's going to shift down 2 units, and the period equals 2 pi, and your phase shift is going to equal positive pi over 4. Okay. Now I'm going to try to draw this in a few different colors. So essentially, if I'm going to draw a line. I think this line is not necessary, but it's going to be a lot easier. So if I go down, sorry, we're going to go down to 2 units. So this is -2. -2. Okay. So it might be easier when you're drawing this is to pretend this blue line is your new axis for your sine wave. Okay. Now, normally we would go 2 pi here. Maybe I'll go back to black for a second here. With a normal sine wave that's not shifted, this would be 2 pi. 2 pi, okay? Now we're shifting it to the right, so we're going to shift it 2 pi plus 1/4, which is 2 1/4 pi, which is 9/4 pi. So now, in this case, let me go back to blue. Okay, so I'm going to start here at 9 pi over 4. Oh, that's hard to read, sorry. Okay, normally we would, and so now we're going to shift it pi fourths here. Pi over 4. And so at this point, let's see here. I'm going to draw, because this is important here. So this is going to be -1. So now I can draw my sine wave. Normally, let's see, so here, just for reference, we know that this would be pi. I'm going to draw these in here because I think it's going to be helpful for you to find these. This is going to be pi. This is going to be pi halves. And then this is going to be 3 pi halves. Okay, now everything's going to be shifted over here. And remember, my amplitude's only a half. So so this value here is going to be pi plus a fourth. Oops, I didn't mean to make that black. That's okay. Probably easier to see.
5 pi
This
fourths.
is going to be 5 pi fourths here. Oh, that was gray. That's funny. Maybe I should go back to blue. Except for that, I don't know if you can see. Maybe I'll make it a darker blue. 5 pi fourths. Yeah, that's a little bit easier to see. And then this is going to be pi halves plus pi fourths is going to be 3 pi fourths. 3 pi fourths. And then this is going to be 6 pi fourths, which is 3 pi halves. 3 pi halves. Okay. Does that make, do
Wouldn't
all
it
these
be
numbers
7
make
pi
sense?
fourths?
Oh,
Because
you're
your
right.
3 pi halves up on
Yep,
your original
yep.
line.
You're right. Oh yeah, you're right. That is 7 pi fourths. Very good. 7 pi fourths, yes. Okay. And then, now remember when we're drawing our thing here, remember the amplitude is only a half. So we're not going to go all the way up to 1. And so my sine wave, in this case, we're starting here, is going to look, whoops, I went too far already. Let's try that again. So it's going to be a relatively flat sine wave. And like I said, this blue line in here is for reference. It's not really needed, but it sure is helpful to draw your sine wave. Does that make sense?
Yeah, it makes sense.
Here we go. Is there anybody for whom it doesn't make sense? You can either shake your head or tell me no. Okay. All right.
I have a quick question.
Okay, go ahead.
If we want to, can we add that, like, because for me it helps me a lot more to understand where to put those new marks. If I put like the pi, the 2 pi, 3 pi halves, and the
Absolutely.
pi
That's
four.
why I did
Perfect.
it.
Okay, perfect. So if it helps us, that's fine to do.
Yeah.
Okay,
Yeah,
awesome.
that's
Awesome.
exactly why I drew all these on here, because even though they're not needed, gosh, they're helpful.
It really does.
Yeah, they're really,
Okay,
really
perfect.
helpful. So yeah. So yeah, technically those aren't needed, but boy, they're helpful. So all right, so let's talk a little bit about the cosine. So once again, the amplitude's A, the period's 2 pi over B, your phase shift is going to be negative C over B. Your D term here in this case, positive D is up, negative D is down. A patient's blood pressure, I don't think I want to do that one. That's an example from the book, but I want to make sure we have the graphs down. So I'm going to skip that one. Graph y equals 2 cosecant of 2x minus pi. So once again, it's probably going to be easier to draw your, the reciprocal of the cosecant is the sine function. Okay, so I was confused. Okay, so in this case, we're going to shift it to the right pi units. So you can go ahead and draw your sine wave in here, and then draw your cosecant function here. So that makes sense there. Oh, that's the answer to the other thing that got put in the wrong place. Okay, that's the answer to this blood pressure question, which I'm skipping for now. Oh, this is all the answer to that blood pressure question, which I was skipping too. Here, I don't know how my notes got all messed up. Oh, what happened there? I'll fix that later. Now, this last one here, this is the one that I think is probably you guys, this is the hardest one. And I've just copied this straight out of the book because it's a little bit hard to follow. If I ask you to graph y equals x plus the cosine of x, okay? Now, what we can do here is we can treat x as its own function, and that's going to be the red line here. That's the y equals x line here. And we've got the cosine of x. That's going to be this gray line here. Okay. Now, the easiest way to graph this is basically what you're going to do. So I'm going to make this a little bit bigger because I know it's hard to see. Okay. So the easiest way to graph this is to say, okay, so I've got y equals x is the red line. I've got the cosine of x, which is this gray line. Okay. So the easiest thing to do is to say, okay, well, when x is 0, okay, so 0 plus the cosine of 0, we should know that the cosine of 0 is 1. And so 0 plus 1 is going to be 1. So I'm going to put a little dot right there. Okay. Now, when, let's go to pi halves, okay? The cosine of pi halves is 0, okay? So that's going to be 0. If x is pi halves, then pi halves plus 0 is simply pi halves. And so when we're adding this here, 0 plus pi halves is pi halves, okay? So we've got so that point is right on the y equals x line, okay? Now, the next point that we can go to is pi. The cosine of pi is what? Who remembers what the cosine of pi is?
-1.
It's -1. So if I've got pi plus a -1, that's going to be pi minus 1. And so that's hard to grasp. So when we're at this point, it's going to be pi minus 1 is this way. So at any rate, essentially what we've got here is we've kind of got a warped looking cosine function. Sometimes it's going to be above the line, sometimes it's going to, because here we're subtracting whatever the cosine is, so it's going to be below the line here. Here it's going to be above the line, and so it's going to be above the line here anyway. And it's going to keep touching the line every time your cosine value. So at pi halves, it's 0. At 3 pi halves, it's 0. At 5 pi halves, it's 0. So we're going to be touching at these points here. So so that's the graph of two functions, and so that'll be this blue line here. Does that make sense there?
Makes sense to me.
Okay.
So does that red line then, does that almost just become like a new x-axis for the cosine?
You could think of
graph?
it that way. That's a great way to think of it. Yeah, just like on my previous graph where I drew this blue line here. Yeah, that is kind of your new axis. That's a great way to think of it. But you'll also notice here, so with the cosine function, you can see it's nice and symmetric. This is not symmetric. You can see that it's not symmetric, but yes, essentially the y equals x line becomes your new axis. That's a great way to think of it.
So if we had a question like this on the test, would we lose points if we drew it symmetrically along that x line?
Yeah, maybe a half a point. That would be, because I know it's hard to draw that. But yeah, it should not be symmetric.
Okay.
So Let's see, somebody asking. Oh, Brian had the same question, so great. All right. Example 8. We're about out of time anyway. Y equals the sine of x minus the cosine of x. Oh, I didn't even do that one. That's on page. Oh, I will add that in there because that's kind of a funky graph too. But it's the same sort of a thing. So, all right. We've got 3 minutes left for questions. Do you guys have any questions for me?
I do.
Okay.
Going back to that graph you just showed us where the x, they said that's the new like reference.
Kind of a likely axis.
Yeah, kind of like it. So
Okay.
the bottom, that gray graph, is that kind of like a reference? Just to show us kind of like how to do the other graph, kind of like the one that you showed.
So this gray curve here is just the regular cosine of x, unshifted. It's just the cosine of x. The red line is your x. It's the y equals x line.
Okay.
And so then the blue line is when you add them together.
Okay, gotcha. Thanks.
And so, any other questions? All right. So as far as homework, so you'll have homework on 2.6 and 2.7. And so the quiz will cover both of those. So hopefully you guys can handle all the shifts. Remember, I always make the quizzes multiple choice because they're easy to grade, and I don't have to grade them except for when I make a mistake and I put the same graph on there twice. Sorry about that. I will try to fix your quiz grades today. I also will try to post a review of everything up to 2.7. I'll probably make it super hard, so then the test will be like, oh, this test is so easy. It seems like people like hard reviews and easy tests. The only concern I have is sometimes I make the review so hard that people are like, oh, I'll never do all these problems. But at any rate, so you'll have 2 quizzes and 2 homeworks due tomorrow. Tomorrow is just going to be a review day. I will try very hard to post the review today, and so I don't expect you guys to have the review done by tomorrow, but if you guys can kind of peek at it and say, oh, these are the problems I have, tomorrow is just going to be you guys asking me questions pretty much the whole time. Does that make sense? And then, of course, Thursday, we will take the test at 8 until 9:30. It will be online. Make sure that I forgot to check and see if everybody's taken the Proctorio quiz. Hopefully you all have. And I just don't want to have any. So if you haven't taken Proctorio quiz, get it done. And that's all I have to say about that, in the words of Forrest Gump. So anything for you, for me? From you, for me? Any questions? Okay. All right, well, I will stop recording, and if you guys want to stick around and study, you're welcome to do that. So.